roughly half a year ago, or precisely on September 25th, 2015, the General Assembly of the United Nations unanimously passed a document called Transforming Our World. Okay, transforming our world. Now, transforming obviously means to change whatever it is. Right? How can you imagine that most conservative people, and politicians are of all sorts, left, right, up and down, they are by definition people who want to maintain the status quo. They are power, so why they want to transform it? And what does it mean to transform this thing? Are they serious? Okay, that's of course the first thing to be asked about the whole thing. Do they really mean what they say? Now, let's look at literature. That is always very useful. There are at least two important literary works that all of you know. One is Alice in Wonderland. And over there in Alice in Wonderland, of course, the story is that she has to run very, very fast just to keep the situation unchanged. And there is a book, Cotopardo. It happens on the island, which now most of you know, the island of Lampedusa. It's a small island, which now is very important because of the immigrants going through that island. So there is an old aristocrat there, and he has a son, or whatever, a nephew, I think, more precisely. And then he says to his nephew, you know, if you want nothing to change, then you have to change the things, just so to be in connection with the world. Now let me go to some of the elementary physics. As you do know, at the moment we seem to be sitting still and not moving. In reality, of course, we are moving very fast with respect to our sun. More precisely, we are moving even faster with respect to the center of the galaxy, and much, much faster with respect to something that we may consider as almost the center of our universe. So the entire concept of motion, and similarly of change, is always in the relative things. So the important thing is the relative things, not what it is ideally there. So when you say that there is no change, it could be quite a lot of change, as I see from this simple fact that we are moving. Now that, of course, is in our perception, in our way, how do we understand the things. So when we look at this transforming our world, which is the title there, what are the possibilities? The possibilities are, just to list all of them. The possibility number one is that there is no change, right? So just as the Count of Lampedusa and Alice in Wonderland, they just simply do not change. Okay? The other possibility is that we continue with business as usual, as it is now. Now that, of course, is changing. We know that this is changing quite rapidly. Then the third possibility is that there are changes which are incremental in a direction that we consciously want to do. The fourth possibility is that there is a revolution. And the fifth possibility is precisely the title that we have, the paradigm change. I'm just listing all of them, what they really are. And just to show some examples of what do I mean in certain cases. Now, of course, incremental changes are all what we have, for instance, constantly nowadays in improving automobiles. Right? These are, until we come to the electric automobile that will be driving by itself and so on. But all of these things where you have a better tire, a faster way and so on, these are incremental changes. And a lot of incremental changes in all of these scientific disciplines. Then there are revolutions. And one revolution that you certainly are quite familiar is what is called the famous Copernican revolution. Okay? That is often referred to a Copernican revolution. Now, and you have to really think in terms of two revolutions, basically, when you apply the word revolution there. First, you have to ask, is that really a significant revolution in physics? and basically is not, because it's either you rotate around the Earth or you rotate around the Sun, and so that is totally irrelevant from the point of view of physics, if you wish. From the point of view, of course, of philosophy, it was very important because for the first time it moved the human being from being at the center to being somewhere away from the center, not necessarily at the periphery. However, as the system developed more and more, the human being went more and more toward periphery. But we'll see what happened with that later on also. Okay, so this was the revolution, which I said was much more the revolution in philosophy, in the thinking, than it was really in terms of physics. Then we have a paradigm change, and really deep paradigm change is the one which occurred at the beginning of the 20th century with theory of relativity and quantum physics. And that is a profound change in everything. First, it is a profound change in physics, because then the physics became a true basis of all natural sciences. To put one very important point, in a famous book by a famous biologist, Jacques Monod, entitled actually The Chance and Necessity, where he actually uses this, I think, Democritus phrase. He says everything is just chance and necessity. And chance, of course, is nothing else than quantum physics, right? This is what is chance, because there you have the uncertainty principle and likelihood that something will happen or not happen, the probability, not the certainty, okay? So this is actually, for the first time, we explicitly in science introduced the concept of uncertainty, which is there to stay. There is no way to get rid of this uncertainty. Everything is uncertain. Now, I understand that Winston, and maybe he will touch on this subject also in this talk, but I understand that yesterday he was presenting brief history of the legality, how the law developed from the time of Roman, or even presumably earlier, Hammurabi and so on, until this time. Let me say that, of course, most of the laws, from my point of view, and I, of course, never studied the law. I am, as a physicist, a habitual lawbreaker, so I know very little about laws. But still, the idea of the law is that you have certain certainties, that you have rules, and so on. Of course, quantum physics does some of the different things. But remember, based on this uncertainty principle, Heisenberg uncertainty principle, we are capable of predicting certain things with an enormous accuracy of 1 in billion. So this is a contradiction in a way, if you want. It does that. But this is not all what this is a paradigm change. Paradigm change caused by physics of the beginning of the 20th century then, as I said, provided the basis of chemistry and biology. And though most of the physicists believe that there are biological laws beyond laws of quantum physics and beyond the theory of evolution, most of biologists believe that all the biology is just these two things, that there is no special law. Now, of course, Stefan, who is an expert there, I hope will correct me there and add a number of important points to these things. And of course, chemistry is based on physics, and of course the same thing is true for astronomy, geosciences, and so on. They are all based on these laws of physics, namely quantum physics, theory of relativity, and so on. It does not mean that, of course, physics can be a reliable guide. And let me immediately tell you one terrible example where physics was going in a totally wrong way. As you know, it was the second part of the 19th century when Darwin came with the theory of evolution. And of course, it was an immediate upheaval among the philosophical discussion, particularly in relationship with many religions. And of course, one important physicist, the most famous physicist at that time, and all physicists are extremely arrogant people, you know, so it's actually none of here, anybody except me is a physicist, so okay, fine, I'm not insulting anyone, and I can certainly say that I'm arrogant. But for instance, you can see that in a famous statement by Einstein, who said, you know, I would really feel pity on God if he did not design the world as my equation tells that, you know. So no, physicists are extremely arrogant, you know. So anyway, there was one of them who was arrogant, and this was Lord Kelvin. You all know that, him from the high school. And he said, okay, fine, I will enter into this discussion about theory of evolution, and I will do this by simply calculating how old is the Earth. And if, of course, turns out that the Earth is of the order of 1 billion years old, fine, so good for Darwin. If it turns out that it is anything less than 100 million years, then that is the end of the theory of evolution. So, okay, fine, that is a good proposition, right? Because if it is if the Earth is here for hundreds of thousands of years or 1 million, then there is not enough time for evolution to develop all of this. Okay, so he calculates, okay, he knows well how to calculate, and he comes up with the result, I believe, of something like 50 million years. Much, much too short for theory of evolution. Okay, did he make a mistake? No, he didn't. He did the best, most accurate calculation, and even people who knew how to repeat the calculation, and most of my students in physics would be able to do this, I won't, but I mean, they will, would come up with the same number. So, what is the story? The story is very simple. Of course, he did not know the whole story. He at that time did not know about radioactivity. Radioactivity, when you take into account the radioactivity, then this number changes to several billion years. And this is as it has been calculated now. And of course, not only that's through help of radioactivity you can calculate and get the right number, but through help of radioactivity you can actually measure it and get the right number, and that right number is whatever, 4.5 billion years. So you see, you have to be very careful if you enter with physics and believe that physics will do everything. No, because our knowledge in physics is extremely small. Okay? Though it is reasonably good, it is still extremely small knowledge, so you should not necessarily go into these things. So, okay, what this major paradigm did was, of course, providing the basis of everything for all natural sciences, except when you go, of course, realizing that you don't know a number of other things. Okay, now, for instance, just so that you have a reasonably short capsule feeling of what we do not know now about physics and what might be very important. One of the things that we don't know, but it is likely most of us physicists believe, is the fact that we all believe that besides this universe where we live in, there are an infinite number of other universes, which are all different from ours, but they exist. And the reason why we believe that these universes exist is that this universe, actually as it is, has brought us back to the time of before Copernicus. When I say that the first thing that Copernicus did was to remove us to the periphery, and we eventually ended up nowhere, somewhere deeply, deeply in the periphery, now our understanding of the universe brings us back in the center again, because this universe, the universe where we live, is ideally suited for us. If anything would be changed by less than few percent, for instance, if the force of gravity would be 1% difference, if the mass of an electron would be changed by few percent, we would not be here. And since we are here, then it means that this universe is finely tuned. So it is fine-tuning to us human beings. Now, that, of course, would be one of the many contributions in the discussion of, in the theological discussion, but it would be cheap. You don't want to prove that God exists in such a cheap way. I mean, that would be extremely cheap. So then physicists come to a conclusion that there are an infinite number of universes, and they are all different. They all have different constants and so on, possibly different laws and so on, and therefore, consequently, in these universes, there are no created human beings as we are. It doesn't say that there are no human beings or quote-unquote human beings and so on. So this is one of the essentially paradigmatic changes that we might be still looking there. Of course, in spite of the discovery of the Higgs boson, which will eventually help us to get the understanding of the masses of the particle in the universe, we still have some of the basic questions which we don't know the answer. Except that stupid answer which we don't like, this anthropocentric answer which says, yes, these constants are as they are because they are there so as to allow human beings to be here and to mess around the world and the universe. So far we are messing around the world, so let's come back. So this is one of the things that is a paradigm change. The other thing that, of course, has produced is a paradigm change of our understanding of fundamental ideas like time, like space. This is all under major new way of understanding. So this is a true paradigm change. Okay, now the question is, what did representatives of 193 sovereign states, when they met in New York, really meant when they say transforming our world? Okay, what do they mean? Are they serious? Of course, one thing is that they are not serious, that they are just, saying, okay, we had the Millennium Development Goals. Millennium Development Goal is good. Every 1,000 years, humankind is shaken by this millennium. 1,000 years ago was also this big discussion about millennial changes, blah, blah, and so on. So the same story is now. And so possibly this is one of the things that they really meant, okay, we will continue with the Millennium Goals, which have been to some extent, of course, fulfilled, to some extent not fulfilled. Or the other possibility is that they are really serious about the world, that they really care about the world, because after all, they are part of this world, and the world is going to a catastrophe. Is our world going to a catastrophe? In many ways, it is. We have considerably destroyed the natural capital. We are overusing the resources we have, and not only that, we are polluting more than we have. If you use a measure, which is called the ecological footprint, then we are well above 1, which would mean that we are just totally using the Earth's capacity and totally polluting it. We are now at 1.4, and by the year 2030, which is the end of the so-called Sustainable Development Goals period that this document is addressing, we would be over 1.5. So that is a very, very serious disaster. To make things worse, we actually, physicists built the atomic bomb, you know that, of course. And then once they did that, they decided that in their journal called Bulletin of the Atomic Scientists, they would put a doomsday clock to indicate how close we are to a catastrophe. And they put it originally at 7 minutes to. Then they moved it to 2 minutes to at the time when USA and USSR exploded their hydrogen bombs. Then it went to 17 minutes after the end of the Cold War, the fall of the Berlin Wall. And now it's back to 3 minutes, with the danger of even being at 2 minutes. And the only reason why it was not put at 2 minutes was that there was something which you all know. It was in December of the last year, the Paris Agreement. And the other thing that you also know, it was the so-called Iranian nuclear deal. which is one of the great successes of what is referred to science diplomacy. Otherwise, it would be at 2 minutes. And there are many reasons why it could be at 2 minutes. So yes, we are dangerously close to the really destruction of the civilization that we have, and we have to do something. So possibly these people that met in New York realized that something serious has to be done. And of course what they did, they actually listed 17 goals and 169 targets. So they are really serious in a way of listing that. Some of them are things that occurred already in the Millennium Development Goals, like, for instance, the eradication of poverty, hunger, and so on, which is, by the way, all the old saying of Gandhi, there is enough for human need, but not enough for human greed, is still valid. That statement is still valid. We could feed the entire human race that exists now. We could even feed up to about 10 billion, and everything would be okay unless we would have some of these other things. However, there are a few other things which are there in these 17s. One of them, for instance, is the pet project of Gary and myself, and Gary gave a talk about that at the Club of Rome meeting, and it was under the title Full Employment. And at that time, I think when I don't know at that time the Club of Rome, but I tried to repeat that talk in my own country, in Zagreb, and the comment was, we are talking nonsense. I mean, after all, the basic idea of capitalism is that not all of the people will be working, that there will be very low employment. And of course, you yourself speak about an increasing automatization, robotization, and so on. So there will be less and less work and so on. Now, nevertheless, these representatives of 193 put really this as a target. Are they serious, or they are just putting this as something there? There is another story, of course, they claim, and I strongly support that all of these goals are there interlinked. Now, it so turned out that the World Academy of Arts and Science, under the auspices of which we are meeting here, actually has been working on these 17 goals for quite some time, as a matter of fact, for the last 5 years. And I can proudly say that we have been working fairly successfully on all of them except one, which is quite good. I won't tell you which one we failed, because this is embarrassing for me and for most of us, but anyway, we even did not dare to attempt that one. Of the 17 goals, but we did work on the 16 and accomplished some of the good work, like this one on the question of the full employment, like the one on the question of education. We started with the higher education, and like the one with the question of elimination of nuclear weapons and all of the other weapons of mass destruction.